I'll try to move things along for you. My name's Craig Kitterman. I'm a Senior Technical Product Manager in the Windows Azure product team at Microsoft. And today I want to take you through just a 200-level sort of introduction to Windows Azure, which is our public cloud computing platform. And before I do that, I'd just like to do a quick survey of hands in the room. How many of you are either using Windows Azure today, parts of it, or there's people in your organization using Windows Azure? Okay, maybe 10 hands. Good, because this is going to be pretty introductory. I'm going to cover a lot of different things, but it's going to be sort of introductory level. We have 2 deep dive sessions going on Wednesday that are going to be done in conjunction with the System Center team, and we're going to get deeper into the management and monitoring pieces of actually interacting with Windows Azure. So if you're interested by that, at the end of the session, I'll give you the session numbers for those, and you can come check those out tomorrow, and we'll go a little bit deeper. My contact info is on the bottom here, too. So what we're going to do, as I mentioned, is we're going to walk through the basics of Windows Azure. We'll start by just talking about why public cloud. What are the interesting bits about the public cloud? And when does it make sense for your business to sort of think about the types of applications and workloads that you'd actually want to use something like Windows Azure for? Then we'll do a level set on the types of cloud offerings that are out there, just so we're all sort of speaking the same language, because there's a lot of sort of buzzwords floating around in the cloud space. Then we'll go into Windows Azure. I'll explain what it is, how it works. I'll show you a quick little demo of how applications are actually deployed to Windows Azure and how you can sort of see what's going on and monitor those things. And then we'll talk a little bit about what it means to you, in your various roles as IT professionals in this sort of new era of Windows Azure and working with that. So there's a few types of workloads that we sort of identified, or application types, that really, really shine in a public cloud computing platform. And you'll notice the key here is variability of traffic. That's sort of the common underlying piece of all of these. Now, when you think about capacity planning, you sort of need to always have the worst case scenario in mind. And you need to have the capacity to handle that worst case scenario so that you don't have availability or performance problems with your users. Well, unfortunately, capacity planning is really hard, as I'm sure all of you know, particularly when you have some of these patterns. So let's look at them very briefly. On and off. This is like the type of pattern you have if you have a batch job that runs maybe every night or every month, something like that. You have a marketing campaign that's short-lived. It's supposed to last for a couple of weeks or a couple of months, and then you need to take it back down. Well, of course, you don't want to go invest in a whole bunch of hardware, lay out a whole bunch of capital expense to go for that worst-case scenario, that maximum peak traffic. You really just want to have resources available when you want them and then shut them off when you don't need them anymore. The second one's growing fast. I think everyone understands that. You're a small business. Things just sort of start snowballing. You can't predict the future, but you need to be able to handle that spike in traffic, because that's sort of the lifeblood of your business if you're a small growth business. Unpredictable bursting. This is also known as the slash dot effect, particularly around web workloads when you can't really control the patterns of usage for your application. You have influx of traffic coming to your application because of some event that happened outside of your control. You need to be able to handle that and manage that resource capacity quickly to absorb that spike. And the last one is predictable bursting. Similar, except for you sort of know a little bit ahead of time that these things are going to happen. One common example here is like Domino's Pizza during the Super Bowl. Of course, they know ahead of time this is going to be the best pizza delivery day of the whole year. So they, the night before, they go spin up a bunch of extra capacity to make sure that they are ready to handle that huge onslaught of traffic that's going to come. They pay for those resources during the time they're using them and spin them back down. So they have a nice ability over time to sort of understand what their usage patterns are and scale their resources appropriately. So when we talk about cloud services that sort of are the tools to go apply to those problems, there's sort of three types of cloud services that people talk about and discuss. So I'm just going to walk through them quickly so we all are speaking the same language. The first one is infrastructure as a service. And this is really about virtual machines that are available to run applications, but they're literally just that. Virtual machines, they probably have some OS on them, and maybe some kind of frameworks, application frameworks, etc. But that's really all they are. They're the same thing as physical hardware, but they're virtualized, and you sort of have to manage those things. This is what everyone's sort of doing today, but doing so in an on-demand way from a public cloud provider. The second one is platform as a service. Platform as a service is sort of a next layer of abstraction above the infrastructure, where you have an application platform only, and sort of the details about the operating system and other underlying configuration details are sort of abstracted away from the application developer. And the last one is software as a service, and this is, of course, delivering software that is multi-tenanted in nature, most likely, and you simply interact with that directly without even worrying about what the application platform looks like, something like Salesforce.com. So when you look at sort of what that actually looks like in terms of which pieces are managed and which ones are sort of provided for you, you can see on the infrastructure as a service, sort of everything from the virtualization layer on down is handled for you. And everything from the OS on up, you need to manage yourself. You need to patch the operating system, security updates, all those kinds of things. Platform as a service, the runtime, the middleware, the operating system, everything is handled for you. And you're delivered a container of sorts to put your application code in and run that code. And that's it. So you're trading off a little bit of flexibility in doing that, but you're also trading off and getting in return a lot of things that you don't need to worry about and are sort of taken care of for you. You never need to think about patching an OS ever again if you're using a platform as a service model. And last but not least, everything in the stack is controlled for you, and as the end user, you simply consume that application as a service, and you don't ever need to think about the servers, the storage, the networking, any of those things. Okay, so now that we have the sort of terminology out of the way, let's look at what is Windows Azure. So Windows Azure is a comprehensive platform for running applications of any type. It allows you to host and execute that code in the public cloud on Microsoft-owned hardware in our own data centers. And it provides tools for management of those applications, for interacting with them in the same way, well, doing the same types of things you do today, but doing them in a new way. The key benefits, of course, are having that ability to sort of map those strange patterns to tools that allow you to sort of absorb all of that in a very cost-effective way, mixing and matching of services, and building things that sort of need to have hybrid connectivity. Some things may have connectivity both on the public cloud side as well as with your on-premise or your own data center. If you have some sort of B2B applications where you need to expose certain pieces of data or certain internet-facing endpoints, you can do that while maintaining other pieces of your applications in your on-premise network. So it gives you a lot of flexibility in terms of how you manage and deploy applications. So there's sort of three core services that are part of Windows Azure. Compute, which is literally just those containers, those platform as a service containers that give you all the capability and a container to put that code in and run it. Storage, we have a very robust storage system, which I'll get into a little bit deeper here in a moment, that allows for very, very high scale and very reliable storage of any kind of data. And last but not least, we have a database as a service offering, which is a relational database as a service. Now, in the compute space, there's sort of a hierarchy of things that you need to understand how Windows Azure works. We have the notion of a service, and you can think of this as your application. This is what you're actually building. You give it a name that makes sense, and this is the actual service. And inside of that service can contain a number of different roles. And those roles can be web roles, and I'll talk about the specific role types in a second. They can be worker roles or other things. And within each of those roles can also have multiple instances that are then load balanced. So that's kind of the hierarchy you need to think about. So the types of roles that we have for Windows Azure are web roles. And you can think of this as a basically web application container. It's ready for hosting IIS-based web applications. All the configuration for IIS, all the server configuration, all of that is sort of abstracted away, and it's ready for some web code. And you simply put that web code into a web role, and it will run it. It'll give you an internet endpoint, a DNS name that you can put CNAME mappings on top of, and you can run your code. It's very simple. A worker role is more like a Windows service. You could think of it that way. It doesn't necessarily have an internet endpoint. It could just be doing a bunch of sort of background processing. It could be managing asynchronous things coming from multiple different applications or services. The web role that's interacting with your customer could be actually dumping work items into a queue. And the worker role could be coming along and sucking those things out of the queue and doing things with them. So just think of it as sort of a service that runs in the background. You could actually expose endpoints on your worker role if you wanted to host some code that's doing something else or interacting with other services. You can add additional endpoints on there, even though it's not running IIS. And the final one is called VM role. And this is a little bit different than sort of a virtual machine in the traditional sense, or something like you'd experience with Amazon AWS. This is a non-persistent VM role. So what that means is you can configure your virtual machine, your VHD, to be exactly what you want it to be, and you can upload that into Windows Azure, and you can run that. But anything that happens during the running of that application is not persisted. And so if you destroy your running instance, everything inside that VM goes away. So it's sort of optimized for things like high-performance computing workloads and things that need to spin up compute power that have somewhat of a complex configuration, run a bunch of jobs, and then spin back down. So it's a little bit more customizable than like a worker role. Yes, sir? As you can imagine, we've received a lot of feedback about adding persistent virtual machines to our platform. So we're definitely looking into that feedback. I don't have anything to announce at this time, but we're obviously looking at the future of the platform and trying to decide what makes sense for our customers. So I don't have anything to announce at this time. So Windows Azure Storage is, as I mentioned, a very highly scalable. It's optimized for scale and speed. We ingest petabytes of data every day. And all of this data is redundant. So you have 3 copies of your data automatically replicated to multiple locations. And that's all sort of handled for you. So if you do a write into, let's say, blob storage of a file, you can rest assured that there's actually 3 copies of that file sitting out there in different fault domains. So if you have a hardware failure on a hard drive that one of those copies is sitting on, no problem. Windows Azure recognizes that one's gone away, and it spins up a new hard drive, a new space for that storage, and moves another copy of the blob, so you again have 3 copies. So all of that is handled for you. You don't need to think about any of that. There's 4 types of storage that Windows Azure supports. We have a simple key value store called table storage, queue, which is sort of a non-transactional based, very simple queuing mechanism. It's most commonly used for inter-process communication or communication between roles. So if you have a web role that the user needs to reset their password, the web role will just dump a message in the queue saying, hey, worker role, when you have a moment, go reset the password for this user. And then the other roles can sort of pick that up and do that. So that's sort of what the queue is primarily used for. Blob is any kind of binary data. So it's a big file system in the sky, a la Amazon S3, if you're familiar with Amazon S3. And the other thing you can do is actually use Windows Azure drives. And what that allows you to do is actually mount to a worker role or a VM role a disk that is backed by a VHD in your Windows Azure Storage account. So you can have a virtual hard disk sitting in Windows Azure Storage, and you can mount that as an NTFS disk in your virtual machine, in your running virtual machine. So there's a few different options there. SQL Azure Database. SQL Azure Database is relational database as a service. And what this means is that when you create a new SQL Azure database, what you're getting is a highly scalable system that has geographic redundancy, that is optimized for availability. And you get all of that without having to think about configuration or management of all of those complexities. It is compatible with sort of the tools and processes that you use today with SQL Server in terms of managing the actual databases themselves. SQL Azure understands TDS, so you can sort of use all the SQL management tools. You can create your tables and your databases. All of your scripts still work there, with a very few exceptions. There's a couple of things that aren't supported in SQL Azure that are supported in SQL Server, but the vast majority of things are very much compatible between SQL Server and SQL Azure. So the data centers where Windows Azure is running, we have 6 global data centers, 2 in North America, 2 in Europe, and 2 in Asia. And this gives you the ability to geo-distribute your application, particularly if you have users or customers that are located around the world. You can actually put the actual compute closer to those customers, so they're going to have a better experience. We also have a CDN, a content delivery network, that's part of Windows Azure. And they're not shown on here, but we have 26 CDN nodes around the world. So you can actually edge cache your images, your other types of content. So regardless of where your users are coming from, they're going to have a really low latency, great experience with that cached content using the Windows Azure CDN. And the great thing about the Windows Azure CDN is that all you need to do is go click a button, in a checkbox rather, in the Windows Azure management portal to enable CDN for your storage account. So say you have all of your images coming out of your Windows Azure storage account, and you're referencing that from, let's say, your web role. All you need to do is go enable CDN, and all of a sudden, all that content will automatically be served out of the most appropriate local CDN node for your user. So they're going to have a really great experience. Now, I talked a little bit about the beginning about the flexibility of public cloud and Windows Azure, and we take it very seriously. We have a lot of customers who are telling us that we're not ready to move everything to the public cloud. We're not even ready to move most things to the public cloud. We like the way things are, but it would be great if we could build new applications that can take advantage of some of the goodies that are available in Windows Azure while maintaining some of our things on-premise and build connectivity between the two where it makes sense. So we built a few different areas of connectivity that give you that sort of hybrid application scenario that allows you to sort of take advantage of the strengths of both the on-premise world and the public cloud world. The first one is a data synchronization. So we have the ability to very easily synchronize data from on-premise SQL into SQL Azure. So you can replicate some or all of your data to the public cloud, either for DR purposes, disaster recovery, or for actually exposing some of that data to B2B type applications. We have a more robust messaging layer called Service Bus. And this is a more transactional type of queuing system that allows you to have common messaging between applications that are running both on-premise and in the public cloud. And last but not least, we have something called Windows Azure Connect for this machine-to-machine secure connectivity. And that actually allows you to have an application that's running in the public cloud talking directly to a server or machine that's running back in your on-premise network. So you might have, let's say, a database that's sitting in your LAN, and you don't want to replicate all that data, say, but you would like to be able to throw an application up on the web that can access some of that data. All you have to do is install a little agent on that machine, and that pokes a hole through your firewall that allows that Windows Azure application to access that machine. And actually, this may be a little scary for some of you who are network administrators, because developers can go do this on their own. And so this is something to be aware of, because people are going to want to do this. So you need to understand what it means for your security and your infrastructure. So when we look at what is the IT Pro experience for Windows Azure, there's sort of the key things that you're going to want to do are the same things you do today: deploy, manage, and monitor applications. Obviously, they're done in a different way. And what I hope over the next couple of days is to be able to show you how that's actually going to work and what you actually are going to want to do. So there's a few tools that we have that are specifically sort of tailored for you to help you with those 3 tasks. The first one is the PowerShell. We have a huge set of PowerShell commandlets that give you full control over the entire Windows Azure environment. So everything on Windows Azure, doing any task on Windows Azure that can be done through the website portal, which I'll show you in a little bit, can also be done through an API. So one of the things the Windows Azure team has done a really good job of is eating their own dog food, as we say. And all of the UI, any UI you get in Windows Azure is going through an API that customers have access to. And that makes sure that we get it right in terms of what the APIs are. And the nice thing about that is it's very easy then to go build PowerShell commandlets that can go poke all of those APIs and do all of the things that you want to do with the service management portal. You can now do and plug it into your existing processes. Remote desktop. So even though we're running platform as a service, and there's sort of limited flexibility in terms of configuration and management of those machines in some cases, we do have the ability now to enable remote desktop into those virtual machines. So when you go put your web code out there, you can sort of forget that it's running on a Windows server and just think about it being a container that's running web code. But if you really want to get into the guts of the server, if you want to go debug a problem and understand what's going on, you can enable RDP on that remote desktop on that VM and get in there and actually see what's going on. This is sort of a nice to have if you really are really trying to understand something and something that's not exposed through the Windows Azure portal. You have your sort of common Windows Server administration server tools, and then of course System Center, which we'll go a little bit deeper on tomorrow. So I'm not going to go too deep on the System Center. I'll talk a little bit at the end about monitoring. But come tomorrow if you want to learn about how System Center integrates with Windows Azure. So now let's talk about deployment. So this is how it actually works. I'm going to walk you through the flow of what it means to actually deploy a Windows Azure application and what it is. So it starts out with something called a service package. A service package is nothing more than a glorified zip file that contains some code. So you're handed this by your developer. It has an extension .cspkg, and it literally is just a container with a bunch of code files in it and some XML files that are manifests for what's inside and whatnot. But the nice thing is now you have this bundle that's very easy to push up to the cloud. Along with that service package is another file, which is just an XML file, and that's your config file. It's a .cscfg file. And that's sort of all of your application settings. How many instances of the application do you want to run? What size of virtual machines do you want? Do you want small, medium, large, extra large? All that data is contained within that configuration file. So what you get from your developer is a cspkg file and a csconfig file. And those are the two things that you need to go and deploy to the cloud. So when you do that, you simply upload this service package through the Windows Azure portal. And I'll show you this in a little bit. And what happens is Windows Azure immediately starts provisioning servers. So it sort of looks through its inventory and says, OK, I've got a couple of VMs on these various racks that are open and available to use. So it goes ahead and hydrates however many virtual machines you need for your application. So in this case, let's say we deployed an application with 2 instances in it. So it went ahead and spun up 2 instances for me. Now it's going to go ahead and put those online inside the virtual data center. The next thing it's going to do, now that it's got sort of the raw Windows Azure virtual machines, is it's going to take that code and actually image those machines with your code. It's going to do it exactly the same on all of those machines. So whether you say I want 1 or you want 100 virtual machines, it's going to have the exact same image. So that one package is going to be written in the same way to both of those machines. Once the code is deployed and those machines are up and healthy, Windows Azure actually sets up the network configuration. So it sets up a software load balancer, too far away from the clicker, and automatically load balances the traffic across all running instances of your application. So that all happens within a few minutes after you push that CSPKG and that CSCFG file up to Windows Azure. So what's the cool thing about the cloud? Once again, infinite scale. Even if you start out with 2 instances in this case, you may want more in the future. So say you have one of these little spikes, planned or unplanned, and you know you're going to need more capacity to service all those requests. So let's go ahead and spin it up to 6. That's great. So Windows Azure goes ahead and does the same thing. It starts up those virtual machines, images them with the code. Once they're up and ready, it puts them behind that load balancer. So now you have load balanced across all 6 of your virtual machines. But again, this is public cloud. So you just got on Oprah's favorite things. You need to go even higher than that? We can do that too. Let's say 92. In a matter of 5 minutes, 8 minutes, You now have 92 machines that are serviceable and load balanced, and all your traffic is being equally distributed across all 92 of those machines. It's that simple. You literally go into Windows Azure, you change a number, and now you have 92 times the capacity you had before. And when you're done, when all the fanfare behind Oprah's favorite things has died down, you have a few new customers than you had before. So now you need 10 machines, but you certainly don't need 92. So you spin all that back down. And the nice thing is you only pay for what you use and when you're using it. OK, so that's a simple scenario, putting an application up there, scaling the application. So now I want to go and update my application. So your developer comes to you with another 2 files and says, OK, I fixed some bugs. I need to update my application. Can you please do that for me? Say, OK. So what do? You do the same thing. You upload that code and that configuration up to Windows Azure. And oops, I think I went too fast here. And what it's going to do is, because you have 2 instances of your application running, this only works if you have more than one. If you have 2 instances of your application running, Windows Azure puts those separately in what's called upgrade domains. And what that means is that it's only going to mess with one of your virtual machines at a time. So you always have one continuously running. And so it's going to update the one virtual machine, put the new code on there, and then bring it back up and reconnect the load balancer. And once that's done, it's going to do the same thing with the other one. So you have continuity and availability during the upgrade. Now, if you only have one virtual machine, it's going to go down. That's why for our full 5 nines SLA, or 99.95 rather, it's required that you have at least 2 virtual machines running. So you have upgrade domain. So the other thing we have in Windows Azure is the concept of a production container and a staging container. And I'm sure you can imagine lots of different interesting, cool things that you can do by having sort of a mirror of your environment that's production environment and staging environment in the cloud, probably like you do in your environments today. And what that allows you to do is actually go ahead and deploy packages into Windows Azure, spin those things up, go test, do whatever you need to do, and the deployment manager who uploaded the package is the only one actually who has the URL for that staging environment. Basically, what Windows Azure does is it gives you some long string like a GUID.cloudapp.net, and that's your DNS endpoint for that staging environment. So you can go hit it just like you would your other one, except for nobody knows it's there. When you're satisfied with what's running in staging, and those bugs actually did get fixed, and there's no regressions, and everything's cool, now all you need to do is go click a button called VIP swap. And what it's going to do is actually, inside the load balancer, just flip the internal virtual IPs from production to staging. So what was staging becomes production, and what was production becomes staging. So now your old production bits are now at that funky URL in staging, and what you put in the staging URL now is on your primary DNS name, and everything's up and running. Now, if you have sessions ongoing, it does this sort of gracefully so that you're not cutting somebody in the middle of a session, and all of a sudden pointing them to the new code. So I think we walked through all that. So I talked a little bit about upgrade domains and the notion of this sort of rolling upgrade. What I didn't talk about is fault domains. And fault domains serve a similar purpose in terms of availability. Cloud's all about availability. And what they do is you can specify that you want multiple fault domains for this application. And what that will do is actually put instances of your application on different hardware that is not likely to fail at the same time. So what I mean by that is, if I say I want 2 fault domains and I have 2 instances of my app, what it'll do is it'll put one instance of my app on server rack A, which has its own power supply and its own network connectivity, and it'll put instance 2 of my app on a completely separate, isolated server rack that has different power and different network connectivity. And that way, if you have a failure of any one of those components, you have at least one instance running. And as soon as Windows Azure detects that that has happened, it will go, all the apps that were in that server rack, it will go provision all those apps instances in another server rack, spin that up, fix the load balancer, and everything's back up. And that's why we can maintain the SLA that we have. So this is kind of what it looks like. Fault domains, you can sort of think of them as server racks. They may not be exactly server racks, but they're across things that can fail. And upgrade domains can be sort of horizontal. So regardless of where your actual instance is sitting, those things can be in the same upgrade domain, which means they won't be pulled off the load balancer at the same time. Just like I showed you in the sort of rolling upgrade example. So what I'll do now is just click over and show you a quick demo of exactly what it looks like to push an application and deploy it in the Windows Azure portal. And then I'll show you how to scale that thing using PowerShell. Okay, so this is what the Windows Azure portal looks like today. It's a little bit overwhelming here, sorry, because I have a lot of hosted services running in my account. But I'll show you what each of these things actually is. So this is my subscription. When you sign up for a Windows Azure account, and by the way, you can get a 30-day free trial. Go to windowsazure.com and sign up. And if you have any questions or need help getting up and running, or want to play with it, stop by the booth and we'll help you get your account set up and play with it a little bit. And this shows up in your portal, and you can have multiple subscriptions. And then they each have a different node here. And then under each of those subscriptions, these are the services that I've created, or you can just think of those as applications that are running inside of my subscription. And now what I've also got here is I've got a staging and a production container. So for this app, which is called MMS Perf Test, I've got a staging container here, and you can see this funky URL that it gives it. That's how I get to my staging app, and it's actually not running right now. If I want to make it run, I just click this start button here, and it'll rehydrate all those VMs and get them going. And this is my production instance. I have one web role running in this production instance. It's called MVC web role, which was the default name that Visual Studio actually gave it, but you can call it whatever you want. And then I have 5 instances of that web role running. So I have 5 virtual machines that are all being load balanced. So anytime anybody hits this URL, mmsperf.cloudapp.net, and hopefully I have good connectivity here. So I'm hitting one of those 5 instances. I don't know which one. And so now if I want to go create a new hosted service, let's go ahead and do that. So I click New Hosted Service, so I want to deploy a brand new application. I pick the subscription that I want to put it in. I'm going to put it in that one. Let's give it a name. Now I get to select the region, which data center do I want it in. And I'm just going to go ahead and pick Western United States. You can say, now then it asks you, do you want to deploy something right now, or do you just want to go create the container and then maybe use PowerShell or Visual Studio or something else to deploy later? We'll go ahead and actually deploy right now, and I want to go ahead and deploy right to production. I'm not going to mess around here. And just go ahead and start it after deployed. Because it can actually do part of the process, which is deploy your code and get the image ready, but not actually start up the virtual machines. And then you can go start those later. So let me pause here and flip over to Visual Studio. So I have a simple app here that's just the canned MVC4 app in Visual Studio. So I'm just going to go ahead, and this is what your developer will do, is they just simply right-click on the cloud app and say Package. Say what type of configuration they want. Say Package. VS does its magic. And if everything works well, I get pointed to a folder here which has 2 files in it. The 2 files that I mentioned, the service package and the configuration file. And so now all I need to do is upload those to Windows Azure. So I'm just going to go ahead and copy that path. And let's go ahead and put Hello Azure. And the configuration. And go. Oh, I need to give it a name. Thought I already did that. Warning. So this is what I mentioned before with our service level agreement of 99.95. You have to have 2 instances running in order to get that SLA. And so this is just a warning because in my config file I only had specified 1 instance. So when Azure read that config file, it said, wait a second, you're not going to get full SLA. So I better let the user know they're not going to get full SLA. So that's all this is. So I say, all right, I accept that. I'm going to be able to live with myself. And now, that's going to take a few minutes to spin up. Let's see, where did it put it? It's going to take a minute to pop up here. So I've got another app that's already running here, this one that I showed you. And I want to show you really quickly how easy it is to use PowerShell to do things with this app. So you'll see right here I have the 5 instances running. I'm going to go ahead and change that to, let's change it to 11. Why not? So here you can see I've installed the Windows Azure PowerShell commandlets. These are available on CodePlex, just an open source package out there that you can install. You can install it as a snap-in or as a module. So I just set up some variables here with my subscription data. There's a certificate that I have to install on my local machine that is also uploaded to the Windows Azure portal, so we have trust there. And so then I simply need to tell PowerShell where my certificate is and what's my subscription ID, which I also get that from the Windows Azure portal. I'll show you where that lives up here at the root node for my subscription. See the subscription ID, so I just copy and paste that in there. And then I can run this get deployment, pass it all that information, and then pipe that to a set role instance count commandlet that will actually change the instance count. So I've gone ahead and said, okay, run this thing on this app that I've already configured, and now I want 11 instances of my thing. And so let's hope that this doesn't blow up. It's executing. Execution complete. So now we should see over here in the portal, in just a moment, this should change and start doing some things. And we'll see that that is going to go to 11 instances. Let me go ahead and just force a refresh here. This portal is running Silverlight, and it doesn't refresh always right away. Sometimes you got to push it a little bit. Okay, so here's our application that we've deployed before. It's up there still trying to deploy. And the one that there we go. Okay, so you can see here my MMS test app now is working on provisioning 11 instances. So it's spun up a handful more instances, and those are all now waiting. So that's one of the simple PowerShell commands. If you come by the booth, we've got a bunch of scripts that can do a bunch of other management tasks, and I can walk you through some of that. Yes, sir.
How advanced is the load balancing? For instance, IIS is running, but the application code is crashed. So I know there are load balancing software out there that can actually go in as a user and test the services available. Do you do that, or just?
That's something you would have to probably use System Center to actually monitor the availability specifically of the app. So unfortunately, Windows Azure doesn't know at that level if it's healthy or not. It only knows if the service is running. But that's a real scenario that you definitely want to set up in System Center. And we'll walk through that tomorrow. Okay, so let's just go ahead and click back over. A couple more things to walk through, and then I'll let you go for Miller time. So as I mentioned, Visual Studio, that's how developers are deploying the apps. That's the easiest way for developers to deploy the apps. when we originally rolled out Windows Azure, we wanted to make it very easy for developers to do that. And I know that probably causes headaches for many of you because it's too easy for developers to go spin up an account and spin up VS and start pushing apps to the cloud. But that is the primary way that they do that. CS Manage is another tool. It's just a command line tool that allows you to do all those things. We have the Azure MMC snap-in. We have the service management commandlets that I showed you. And there's other third-party tools that allow you to look into your storage account and do management and monitoring that way. So there's lots of third-party stuff spinning up, and that's because, again, everything has this common set of APIs that anyone can use. So third-party ISVs and whatnot can go create tools to do all these things. If Microsoft doesn't do it right, which sometimes we don't get it right on the first time, believe it or not, thankfully third parties are there to help out as well. We already talked about the commandlets. So this is sort of, in talking to some of my colleagues, this is sort of what we think about, and I'd love to get you guys' discussion and feedback around this maybe at the booth and through the sessions tomorrow, what you think about this. So this is how we see sort of Azure deployment with the proper controls in place, using proper deployment methodology rather than developers pushing from VS to the cloud. So it starts with the developer handing off those two files to the deployment manager. The IT professional that's involved here goes and actually provisions the hosted service in Windows Azure, provisions the storage accounts that are going to be used by the application, or creates the SQL Azure database, depending upon what the application needs. You would actually manage the certificate process. So as I mentioned, there's that trust between any sort of tools that are going to be deploying things through the Windows Azure API. You need to have a certificate exchange. You don't if you're using just the browser and the portal. But if you want to do anything more advanced, you need to manage some certificates. So there's obviously some certificate exchange work that needs to be done there. Configuring and deploying, how much capacity does this app actually need? When does it need it? Setting up the network configuration, setting up the remote desktop connectivity, all the diagnostics that are involved. If you're going to be doing things with System Center, you need to turn on various performance counters and diagnostics. You want to make sure that those are all set up and working in the configuration. And of course, deciding what are the upgrade domains and the fault domain configuration that we want for this app. Is this mission critical or not? How much do we want to invest in sort of having extra instances and making sure that we have full availability of the app? And so all those things require sort of a lot of work from the IT department to make all those things work right. And then, of course, deploying the service. So I mentioned before that you can remote desktop into a VM, which is sort of I wouldn't really call it a monitoring technology, but it's just if you really need to get in there and see what's going on, you have that capability. You have Windows Azure Diagnostics. You can configure any Windows Azure application. There's a bunch of libraries and APIs for that application to record all kinds of performance counters and data, and it goes into Windows Azure Storage in tables. And then you can come behind that and use System Center or a number of different third-party tools that are out there to go suck that data out of those tables, Windows Azure tables, and take a look at what's going on. So that's another powerful way to peek into those apps and understand what's happening. Bless you. And then, of course, the Windows Azure Management Pack for SCOM. And we'll go into that more tomorrow. I don't want to steal the thunder from tomorrow. So we'll skip that. So here's the things that you can monitor. IIS logs, crash dumps, performance counters, event logs, debug trace statements, and infrastructure events. So it's a pretty robust, verbose logging system if you get all those things turned on and you have access to all that data. So basically the way that it works is when your role actually starts up, you have to have the code in there to turn on the diagnostic monitors, and then those logs are sort of dumped on an interval, and you can set the interval. And obviously, it requires a little bit of compute and network to ship those logs into Windows Azure Storage off the running VM. So you sort of have to think about how often you really need fresh diagnostic data, and then you can throttle that number accordingly. But it's really easy to configure, and I can show you that in the booth or tomorrow as well. We won't talk too much about that. The sessions where we're going to go deeper on the management and monitoring piece are tomorrow, 11:45. We're going to do part of it. We're going to get an app up and running and set up some basic monitoring and system center. And then in the afternoon, we're actually going to take it a step further and have some actions actually happen and scale the application based on what's coming in to the performance monitor. And so we'll sort of go all through that process end to end. And I'll be with my colleague Adam Hall from the System Center team, so we'll be working together on that one. So with that, I'll go ahead and open it up to questions. Anything at all? Yes, sir. It's helpful if you don't mind going to the mic, because then everyone can hear and I don't have to repeat. But
so, is this on? Okay.
No.
So, as new Patch Tuesday patches come out, how can you mitigate which of your upgrade domains get the patch on the first month of availability, the second month of availability? How can you control how compatible your app is with the new level of patching that comes out?
That's a good question. So there's a couple things I didn't mention. One is, to start with, you can turn off you can turn it off such that you don't get any patches. Like if you're really worried about compatibility, you can actually say, I don't want any upgrades until I tell you to touch my VMs. They're running, they're very fragile, just leave them alone. So you have the ability to do that. Other than that, other than setting up your upgrade domains, there's really no more granular control that you have over when those things take place that I know of. I don't think you can do that.
Can you set your application not to take updates and then periodically move instances of your apps into an upgrade domain?
Yes.
Test them out for a little bit and then flip them over?
Yes, you could do that.
Okay.
Absolutely.
Thanks.
Yep. Any other questions? Sir.
So when deploying the service, basically the service is not just the application, just the code. It may have dependencies like, because this new service might be, it may need a new table in the Azure database. And if I deploy these things, do I need to deploy a separate, do I need to do a separate deploy? One is for the application, the other is to the database update?
Absolutely, just like you would today. You go put the web code somewhere to run. Somebody needs to go and do the database schema changes or whatever. So, I mean, that process is exactly the same. You would need to do that. And in which case, you may want to have, two SQL Azure databases, sort of a production and staging type of environment there as well, and then just swap your connection strings. And you can actually go into Windows Azure in the portal even and change configuration values on the fly, and it will update. It'll cycle your application and update it. So if you want to repoint to the new updated database schema, you can just do that on the fly. But you still have to go through that process if there's dependencies, absolutely.
Okay.
It's the same thing.
Okay. The other question is for the tool environment. Just now
I'm
you
sorry,
mentioned,
sir.
I'm sorry. Just now you mentioned tool environment. You can define tool environment. One is staging environment. The other is the production environment. Mm-hmm. And when you have the two services, say I have one service is one version, maybe two in staging, and one version in production. When you switch this service, it just switch the service itself, right? It just doesn't care about the dependencies. It's just the instance,
correct.
The application.
Correct. Everything is exactly the same. The only thing that changes is the internal IP that the load balancer is referring to. It doesn't change anything else. So if you need to change some configuration, you're going to want to change the configuration, your connection string, whatever. You're going to want to change that before you do the VIP swap.
Okay, I got
it.
Can I have another question?
Yep.
Just now, I think there is another gentleman asked another question for the deployment. Say, if you do a deployment, you have 11 instances, right? Based on SLA, you can deploy one instance one by one. So somehow you have some problem. This developer made some mistake and put a bad configuration there. So during this deployment, you deploy the one service and you start it up. Somehow it's down, and you consider it's up. Then you do another, and in this case, you may bring down all 11 or 10 instances, all the instances in the cluster. So will that happen if this case?
So
this
I'm
case.
sorry, are you asking if you want to, can you have them go ahead and update all at once?
Yes, because say if I create a new package and I want to deploy it to the cloud environment, somehow when they make the package, they put a bad file there, either a config file or some other DLLs or whatever it is, right? When we deploy these things, say I've defined 12 instances in the environment, in the Azure environment, and because this bad application, new version, can it bring down all the instances, or during the deployment somehow you can identify the problem?
Can one bad instance bring down other instances?
No, the new application.
The new application. If I understand your question, I don't think it can bring down other running applications. But I may be misunderstanding. I'm sorry.
Okay, maybe I need to
Here,
make it more.
let's chat after. I'll try
Okay.
to answer your question. I'm sorry.
All right.
Yes, sir.
I just want to ask again, you mentioned earlier about an eval being available. So there is an eval opportunity.
I'm sorry.
Is there an evaluation? You've mentioned that there's an evaluation opportunity available to
Yes,
us.
absolutely. Absolutely. Go to windowsazure.com. There should be a button right on there that says free trial, 30-day free trial. It takes you probably 5 minutes to get situated with your free trial. You do have to put a credit card number in, which spooks everybody, but we will not charge you no matter what. If you try to use more than you're allocated for your preview, you just can't. So the credit card number is only for fraud protection reasons, but it's very quick and easy to get set up. And if you have any questions or need help getting set up, or you want to, I can give you a couple sample apps if you want to just deploy and play with them. I'm happy to do that for you at the booth. And by the way, please fill out your evaluations. I forgot to mention, I think I accidentally pulled that slide out. Oops. Please fill out your evaluations. I'd love to get your feedback on the session and see what we can do better next time. So if there's no other questions, thank you for your time. I appreciate it, and I'll see you at the booth.